Here we have a linear inequality in two variables. We want to express the solutions of that linear inequality in two variables. Well, remember, a linear equation in two variables has an infinite number of solution pairs. And likewise, a linear inequality in two variables has an infinite number of solution pairs. And the way we express those solution sets is with a graph. So just as we graphed the solution set of a linear equation in two variables, we have to graph the solution set of a linear inequality in two variables. This is problem 9 from your review sheet. The way we start is we first graph the equation, because we need to establish our line, because on one side or the other of the line would be the ordered pairs that make 2x plus y less than 6. The only way we can figure that out is if we first establish the line. And the line is where 2x plus y equals 6. So we first graph the line. Well, let's get our intercepts. Those should be pretty easy to find with this equation. If x is 0, that term, 2x, becomes 0, so it contributes nothing to the left side becoming 6. The only way for the left side to become 6 is if y is 6. Let's find the x-intercept now by letting y be 0. Well, if y is 0, that term disappears, contributing nothing to the left side becoming 6. So the only way the left side can become 6 is if x was 3. Now let's find another ordered pair solution. What if I let x be 1? 1 times 2 is 2 when I let x be 1. So now this is 2. 2 plus 4 would equal 6. So y has to be 4. And I have 3 points that I can plot in order to draw my line. We have the y-intercept, 0, 6, which would be this point. We have the x-intercept, 3, 0. And we have another solution point, 1, 4. And now we need to draw our line. Well, we have to pay careful attention to the inequality so we know what kind of line to draw. If the inequality simply says strictly less than or greater than, then that means the line doesn't work, because the line is the ordered pairs that make it equal to 6. In this case, we don't want the pairs that make it equal to 6. If this was less than or equal, or greater than or equal, we would want the pairs that make it 6. When you want the pairs that are on the line, you make the line solid. When you do not want the pairs as part of your solution set that are on the line, you make the line dashed. So in this instance, we need to make our line dashed. Oh, that was a terrible line. So here's our line, and we made it dashed because we don't want the ordered pairs that are on the line. Those would make it equal. We don't want equal as part of our inequality. Now we have to figure out which side of the line contains the ordered pairs that make 2x plus y less than 6. And the technique we use is to simply pick a point not on the line that's on one side or the other. And let's take the origin. If we were to plug in 0, 0 for x and y, 2 times 0 is 0, 0 plus 0 is 0, 0 is less than 6. Is that a true statement? Yes, it is. So that tells us that the solution set is this range over here, this part of the plane, because these are the points that will make 2x plus y less than 6. And remember, what we do to express that is we graph that side of the line by shading it. So that's our expression of all of the ordered pairs that make 2x plus y less than 6. That's our picture of the solution set of this linear inequality in two variables.